are going to discuss about smart factory control using sequential circuits. Generally, the sequential circuits are used for storing the memory elements. So, the factory like Siemens and Robert Bosch company, they are using the sequential circuits for making their process in daily manner. Especially for sequential circuits, it will be used for storing the data. Like D flip-flop and JK flip-flops are using to manufacturing the data in a stored manner. The design thinking is an approach in which all those 5 stages will be used to implement to make a sequential circuit as an essential factor. Let me see how these 5 stages will be implemented for our sequential logic circuits.
So the first stage is an empathy. I am going to say an empathy for a smart factory control system by using a sequential factor. So the smart factory system, how it understands the people who works on the factories by operators and the workers and the engineers who work them. They face a problem like they work on manual, they can't move to an automatic machine. They face so many problems using this. And for an example, when we get the empathy for an solution, we can design according to that, so they feel free.
So we are using sequential circuits so that we can make it more easy for the users.
So
next we come to the defect part. From the empathy part, we can compare further. From what is the actual core problem? That is when the workers are facing the problem that manually they cannot overload. They are not able to overload manually all the products. So, for example, we can take an assumption as let me take an example as a box. A box is kept in a built conveyor where it's we are using the 3 types of sensors as an input. First of all, using the first M1 input. When the box is placed on the built conveyor.
So here we are using flip-flops for getting the inputs.
We are using the flip-flop circuits, so it can save the memory from the past inputs. So when the box is placed on the built conveyor, it actually starts to run. So it is the first step of the sensor.
So that it makes a smart conveyor system.
The belt can easily move on. So after this is the first M1 sensor, and next in M2 sensor. After the certain moving on of the box, it need a pass for it needs a barcode scanner or any other quality check from the previous process. So here the suitable for flip-flop is very useful, sir. And also
it makes a circuit more
convenient. So after that the next stop, after that the endpoint, after all the processor, it can check out the M3 sensor. So finally the box is moved to the last step at the endpoint. And also verifies whether the box is properly quality checked, the barcode scanner or completely done. And after that, the output is taken as from the another sensor with the help of that. The overall process.
So the table has to be verified based on the present input and the output.
And the past inputs. It can be the pre-checked with the past inputs, like from the M3, M2, and M1 inputs. The output at last it can be verified.
Next, I'm going to explain about the item. It is to determine the conveyor belt operates automatically through sensors and logic control. First, the conveyor belt.
So they are using flip-flop for making the circuit to be operated in a proper.
And used to make more sequential circuits, which the output depends on only the present state input, not directly to the sensor inputs. And this machine is preferred
because based on the present inputs only, it can be able to transmit the data to the next state, so that we need to, in order to check the conditions of the states.
And this machine is preferred only in the industrial state because it is stable and reliable operations. There are 4 main states in operations. First is idle, it is used for conveyor off, and next is idle and next it is used for the running off, and next is inspect to pause at the midpoint of the sensor state, and last is stop to stop the conveyor belt. And there are many main components used today. First is 3 flip-flops for state control, and next is unmet all logic gates for
so unmet logics are used for switching.
Here there are 5 different steps in a prototype. In state diagram,
They are given present state and we have to given the conditions.
running and to inspect and to stop. Likewise, they are created S1, S2, S3. And the second step involves state encoding, where each state is given a binary code. A for 00, B for
So if you want to move the one state to another state, then we need to verify the next state conditions so that it will create another output conditions.
Next, logic circuit. Logic equations are created and simplified using K-maps to reduce the gate count, and D flip-flops are used to store the state
Storing data.
And on the or not gates are used to
Normally used for making the operation more efficient.
The main goal of testing part is to test the prototype which is being to have a successful one. So that in this part of the smart factory and system, we need to test the prototype which is based on sequential order. So that we need to fix more circuits and flip-flop, ready flip-flop based on memory input that we give it to the flip-flops, and it works on it. For example, it works on the sequential order of A, B, C, initial part, and D is the final part. And again starts from the circuits we implement into the missions. So it will be easy
So itself, they will be able to check the
before order it will be made by a production means we need more amount of humans to do it later. So it will be more efficient for us. So that for example, it is mainly used for the systems. It is mostly used in all the manufacturing industries and factories and operations works, and you have to have a safety and more performance things. It is used to calculate the power efficiency, time variance in the system, and also the performance of the object also.
So after finalizing all the inputs, we have concluded that so the machine has to be monitored very clearly by everyone, and moreover, it will make it as smarter when the conditions should be satisfied based on the sequences. Thank you.
Thank you.